All right, good morning. We just finished talking about a quiz, and now we're kind of review some things with limits. And McKenna, these limits right here are all headed to a particular number. And that's how we talked about previous limits, okay? And so one of the things I want to talk about, because I did go to an AP conference, and they said that AP is looking closer and closer to limits all the time. One of the ways that I can figure out what this limit is by substitution, correct? The reason I can do substitution is that x squared plus 4 is a continuous function. Would you agree with that? And Jeremiah, how do I know that's a continuous function? Because it's a polynomial, right? So that means, McKenna, if I want to know what, as I move along the x-axis, as I approach 2 from the left and the right, I can do the easiest way to figure out what that limit is by doing substitution. Would you agree? And what do I get if I do substitution in this case? Get 8. Okay? That means that graph, as we approach 2 from the left to right, is headed to the y value 8. Now this one's a little bit different. Right, Maureen? Because if I put a -2 in here and a -2 in here, I get that terrible 0 over 0, correct? So in this case, what are we going to do? We're going to factor. And I'm going to have x plus 2, x minus 2. And the x minus 2's simplify, correct? The x plus 2's simplify. It'd be nice if I wrote down the right problem. They simplify, right? And I now can do that substitution that I wanted, right? Because this x minus 2, it's a different function than this x squared minus 4 over x plus 2, right? Remember me talking about that? They're different functions. They're exactly the same, okay? There'll be a line that looks like this, correct? Except x minus 2 doesn't have a what in it that this does. If I would graph this, okay, it would be a line at x minus 2, right? And what would I have to put here? A hole, correct? This doesn't have a hole, does it? But this does have a hole, right? Because I'm not allowed to put a -2 in the denominator here. But I've eliminated that problem, haven't I? And so this, if I could draw a different color, is actually this one right here, the black line, right? They would coincide. So I can get substitution, and I can get that limit to be what? -4, right? Now again, I have an issue here, right? I'm going to get -1 over 0. If I plug in 0 here, and I see I have a square root, John, do you know what I'm supposed to do anytime I see that square root? Multiply by the conjugate. And the conjugate in this case is what? And when I do that, I get the limit as x goes to 0. And up here I'll have x times, the square root of x times square root of x is x, right? The conjugates mean I have no middle term, right? I have -1, and down here I get x times square root of x plus 1, and I'm headed towards 0, and nothing simplifies, does it? No. So I wonder where this is headed towards if I get close to 0. I'd have like 0.9, or excuse me, 0.1 up here, right? If I'd be to the right. If I'd look at, if I would, over here I'd have 0, right? Which does not exist. I'm drawing a little table here. And over here, if I'm to the left, well, I can't even put a negative 0.1 in here, can I? Right? So I only can approach this from the right. Does everybody see I can't even put a negative 0.1 in there? Well, okay, what's happening in here then if I put 0.1, 0.01, 0.001? What do you think is happening? Because I'll get, if I put 0.1 in there, I'll get a negative 0.9, right? Correct? And then I'd have 0.1 times the square root of 0.1 plus 1. What do you think is happening there? Getting smaller, so you think it's headed towards 0? Think it's negative infinity? Well, let's find out. I'm going to go to a table. Is that okay with you, John? You're right. You found out already? So let's put 0.1 in there. 0.01. 0.001. 0.00001. Ooh. Would you agree it's going to negative infinity? Okay. What about this one, Cullen? What do you think about this one? So I'll have like 1 over 0.1 squared, 1 over 0.001 squared, 1 over 0.00001, that squared. Yeah, it goes to positive infinity. Because the smaller this number gets in the denominator, right, the bigger the overall number becomes, correct? All right. So all of these are looking when we're headed in. Does that make sense? We're headed into a point. We're going to talk about end behavior. What does our graph look like as it heads to humongous numbers? So it's headed towards infinity. 1,000, 10,000. We're not worried about what's happening in the inside. We're worried about what's happening in the long run. Does that make sense to everybody? And we're going to look at this one first. Okay, we're going to take the limit of this. Looks at what happens to y when x is huge. So that's the first one we're going to look at. And we're going to look at the next page. And what I did is I graphed it. And I didn't have to go very far out. I went to negative 10 and 10. And I don't care what's happening right here. I want to know what these branches, and it looks like those branches are flattening out. Would you agree? It looks like it won't cross the number 3 for a y value. Does that make sense? It gets very, very close to that 3, and we call this a horizontal asymptote. And it looks as you approach x from the left and the right, it's headed towards 3. If I would put it in a table, what I did is I put 0 in there, and then I made my numbers bigger. And you could see that, in fact, if I made the numbers big enough, it would eventually round to 3. And so that's my limit. Okay, does that make sense? Let's go to the next page. Well, if we do it analytically, which means I'm going to do it in an algebraic form, we need to know two important limits. So if I have a constant here, and the constant I chose was 2, and I put big numbers in the denominator, and I cube them. So it starts out as 2 over 10 cubed, 2 over 100 cubed, 2 over 1,000 cubed, 2 over 1 billion cubed. What would be my limit? What's happening to this? Where am I approaching? I'm approaching what? 0. And over here, what I have is negative infinity. So it's the same type of idea, but over here I'm going to have 2 over a negative 1,000 cubed. So it's 2 over a very large negative number. Would you agree? Where is that headed? Still 0. So in other words, and the way I'm going to write this is I'm going to write it like this. If x is headed to positive or negative infinity, and I got a constant up here. The constant I chose here, and this is when I wrote this out, was 3, but let's say it's anything, and x is some power, and that power is positive and it's rational. Okay, and r is greater than 1. Or excuse me, greater than or equal to 1. That means this thing is going to be headed to 0 automatically. Actually, I think r just has to be greater than 0, more than I think about it. Okay. So let's take a look at this. If I take the limit of this, 4 is not changing. The only thing that's changing is this. In fact, I can write this as the limit as x approaches infinity of 4 minus the limit as x approaches infinity of 7 over x squared. Well, this x does not affect that 4. It will always be 4. What is this going to become? 0. So I'm going to get 4 minus 0, and I get a limit of 4. Are we okay with that? Now, let's take a look at this, and I'm going to show you some algebra here. I'm going to try to change this numerator and this denominator into this type of form. And what I do is the denominator gives me the hint. And so what I'm going to do is I'm going to take 2x plus 5, and I'm going to multiply that by 1 over x to the first. Why did I choose x to the first? Because this is x to the first. And down here, I'm going to take 3x plus 1. and I'm going to multiply it by 1 over x to the first. And since I'm moving away from 0, that's what that means by going to infinity, I don't have to worry about this being 0 over 0, do I? I'm a long ways from 0. And what do I get? I get the limit as x approaches infinity. Well, if I distribute this, I get 2 plus 5 over x, and I get 3 plus 1 over x. Are we okay with that algebra? What do I get as an answer? Does anybody want to take a chance? This is going to become what? What's this going to become? What am I left with? 2/3. Now, if I were to graph that, and I'm going to put in parentheses 2x plus 5, parentheses, divided by parentheses 3x plus 1 parentheses. And I'm going to change my window. I'm going to go from negative 10 to 10. And over here, I'm going to go from negative 1 to 1. Exit draw. Okay, now, let me make this even longer. Negative 100. And let's make this negative 3 to 3. Now, I don't care what's happening here, do I? I only care what's happening at the ends. Do you see how these are starting to flatten out? In fact, if I put in 2 divided by 3, do you see over here? It looks like it's approaching it from the left. And do you see how it's approaching it as I go to the right? So the horizontal asymptote doesn't exist here. It only exists far out. Does that make sense? There is a vertical asymptote, correct? Because when we take a look at this, we cannot have a negative 1/3 in the denominator, can we? That would give us 0 in the denominator. So there's both a vertical and a horizontal asymptote. And that's why you see this go suddenly up and suddenly down. Now let's take a look at this one. Again, I'm going to do it algebraically. So I'm going to take the limit as x goes to infinity, and I've got 2x plus 5. And down here I have 3x squared plus 1. And I do not want this going to 0, because I have issues if it goes to 0, correct? So what I'm going to do is I'm going to multiply this by 1 over x squared. And I'm going to multiply the top by 1 over x squared. Where did I get that x squared? That's the power right here. It's the power of the denominator that dictates what I'm going to multiply by. That gives me the limit as x goes to infinity. If I distribute that, I'll get 2 over x plus 5 over x squared. And down here, I'll have 3 plus 1 over x squared. I'm going to pause there. Does everyone understand my algebra? What's the limit of this numerator? Both of these fractions are going where? 0. What about down here? What do I get for a denominator? 3. And what is 0 divided by 3? 0. Now, we're going to start talking about shortcuts a little bit. Here, and maybe this is what you learned last year, I have a rational expression, correct? The degree of this term is 2, correct? The degree of this term is 2. When the degrees are the same, my limit is the leading coefficient of the biggest term. You notice how when you guys were first learning algebra, we said, hey, when you write polynomials, we want you to write them in a particular order. The largest exponent first, and then next smallest till you got to one where there is simply a constant. Am I right on that? Okay, well, the reason why is that tells us the degree of the polynomial. Here the degree is 2. Here the degree is 2. My leading coefficient here is 2. My leading coefficient here is 3, correct? So the limit of this is 2/3. Had you heard that before? You remember that? So right away, I could have said that this was 2/3 also, because the degree of this is 1 and the degree of this is 1, correct? And whenever they're the same, both the numerator and the denominator has the leading coefficient. It's the leading the leading coefficients are the limit to the rational expression. So you'll see me give you a problem like this. You'll get a problem like that. Well, what do you suppose the answer is? 5/3. Because the degrees are the same, here are my leading coefficients. I could multiply the top and the bottom by 1 over x to the 100th, correct? And I would get 5 here. I'd have 3 over x to some power. I'd have 15 over x to some power. I'd have 75 over x to the 100th, right? These terms would all go to 0. I would be left with 5 in the long run. Read okay? All right. Now, let's look at this one. Degree of 3, degree of 2, correct? When this happens, okay, it's going to be hard to see. I'm going to shift my windows a little bit. See what it looks like in the long run? Doesn't that look like a straight line? If I change it a little bit, oh, maybe it's hard to see. You can see the straight line right here. Can you see that? That's an oblique asymptote. So what we do here is when there's a difference of 1, you're going to do long division. So what does that look like? 3x squared plus 1 is going to go into 2x cubed minus 5. Excuse me, plus 1, not plus minus 5, plus 1. Okay? Oh, this is 5. This is 1. This was minus 5.
No,
Is that
your circle is covering the part where it makes it plus 5. The numerator is plus 5? Yeah.
Oh, I see what you're saying. Because of my poor handwriting again. Alrighty. So what do I make, and here's, again, I'll review long division. What do I have to multiply x squared to make it x cubed? X, correct? Now, what do I multiply 3 by to make it 2? 2/3, very good. So I have 2x cubed, and then when I multiply this, I'm going to have plus 2/3 x, and I'm going to subtract, and I'm going to have 0, and I'm going to have, I guess I'm going to subtract here, a negative 2/3 x plus 5. What do I multiply 3 by? Oh, I don't have anything to multiply this by, do I? Correct? Would you agree? Right? So this right here is my limit, 2/3 x. So if I come to this graph, there I go, and I put in 2/3. No, that's not what I want. There we go. Do you see how it kind of merges right there for a line? Again, I don't care what happens around 0. I only care what's there. So that's an asymptote that line cannot go beyond. The graph cannot go beyond. All right, let's take a look at the next page. I just want to finish with these, and then I will be done for the day. We'll finish up tomorrow. So if I would take a look at these, let's say I have this. F of x equals 2x plus 5 over 3x squared plus 1. Here, this has a degree of 1 and this has a degree of 2, correct? This is going to get bigger, isn't it? Correct? So that means in the long run, you're going to get 0 as your limit, because this degree carries more weight. So if I plug 0 into here, I get 5. And as I go right, it's going to go like this and flatten out and get close to the x-axis. And as I go left, it's going to get closer to the x-axis. If I have this, now these degrees are the same. That right here I'm going to have an asymptote, a horizontal asymptote at x equals 2/3. And my graph right here again will be at 0, 5, because I can plug 0 into here. But now my graph looks like this. And if I have this, I'll put a third one in here. And I'm going to have f of x equals 2x cubed plus 5 over 3x squared plus 1. Right here's our point again, 0, 5. But I have a line here that's an asymptote. And that equation is y equals 2/3 x. That my graph looks like this. In that fashion. I'm going to stop here and generalize tomorrow, okay? And then we'll talk about what we do if we have square roots. We'll go through a few examples, and then you should have some work time tomorrow. Does that make sense? All right.